Question 1. In a modern context of residential HVAC systems, an HVAC technician named Lewis is troubleshooting a central air conditioner that has low cooling capacity and longer runtime. Upon measuring, he notes that the suction pressure is abnormally low, superheat is excessively high, and the evaporator coil appears dry. The ambient conditions are normal, and airflow across the coil has been verified to be within design parameters. What is the most likely cause? System behavior: A. Oversized compressor causing liquid slugging. B. Thermostatic expansion valve TXB stuck partially closed. C. Condenser fan motor failure. D. Low indoor return air temperature. Answer. Correct answer. B. Thermostatic expansion valve TXB stuck partially closed. Explanation. A stuck partially closed restricts refrigerant flow, resulting in high superheat and low suction pressure, indicating insufficient refrigerant reaching the evaporator. This also causes the coil to remain dry and system cooling capacity to drop. This aligns with ASHRAE refrigeration cycle diagnostics. Option causes opposite symptoms: floodback. Option C results in high head pressure, not high superheat. Option D affects load but not pressure readings directly. Question 2. When considering the safety protocols for residential HVAC service, which of the following actions constitutes a violation of OSHA's standards related to electrical safety during maintenance of split system condenser unit? A. Wearing ANSI 0.1 rated safety glasses during brazing. B. Using clamp meter to check amperage with the panel cover removed and no lockout applied. C. Grounding the compressor shell to the panel ground. D. Using Class 0 rubber insulated gloves while testing voltage. Answer. Correct answer. B. Using a clamp meter to check amperage with the panel cover removed and no lockout applied. Explanation. Per OSHA 1910.147, LOTO standard, energized components must be denergized and locked out before servicing unless justified. Testing amperage without lockout violates ARP, flash and shock safety protocols, even with PPE. A, C, and D all comply with PPE and grounding standards. Safety protocols prioritize eliminating hazards or PPE reliance. Question 3. To illustrate this point, consider a technician named Erica performing a diagnostic on a two-stage residential heat pump. She suspects the indoor air is overly humid despite the system running continuously. She measures dry bulb and wet bulb temperatures and calculates the enthalpy and relative humidity. The system appears properly charged and air filter clean. What psychrometric issue is most likely affecting the humidity removal? A. Bypassing the coil due to undersized return duct. B. Oversized system with short cycling. C. Low indoor airflow rate causing coil frosting. D. High indoor airflow rate reducing latent heat removal. Answer. Correct answer. D. High indoor airflow rate reducing latent heat removal. Explanation. Too much airflow reduces contact time between warm humid air and the cold coil, reducing latent heat removal and leading to higher humidity. This aligns with ASHRAE fundamentals, which show latent capacity decreases as airflow increases beyond design cm/ton. A restricts airflow. B doesn't apply to a continuously running system, and C would. Question 4. A key distinction between various HVAC motors is how the speed is regulated. In a typical residential air handler, what is the primary advantage of using an electronically commutated motor ECM over a permanent split capacitor PSC motor in terms of airflow management and energy efficiency? A. ECMs use brushes for higher torque startup. B. PSC motors automatically adjust to static pressure changes. C. ECMs maintain consistent airflow under varying static pressures. D. PSCs are variable speed and use electronic control modules. Answer. Correct answer. C. ECMs maintain consistent airflow under varying static pressures. Explanation. ECMs use microprocessor-controlled electronics to adjust speed and torque, maintaining constant airflow under different duct conditions. Critical for proper temperature and humidity control per dose efficiency standards. PSC motors are fixed speed and cannot compensate for static changes. ECMs are brushless, like answer A. Question 5. By evaluating the function of HVAC control systems, a technician named Marcus is reading a residential air conditioner's wiring diagram and identifies that the indoor blower doesn't start during cooling call. The thermostat is calling for cooling and the condenser is running. Using the schematic, he checks for 24 at the GU terminal and finds voltage present. Which component should Marcus check next based on the wiring diagram logic? A. Contactor coil in the outdoor unit. B. Reversing valve solenoid. C. Blower motor relay or control board output. D. Low pressure switch in the suction line. Answer. Correct answer. C. Blower motor relay or control board output. Explanation. Presence of 24 V. G confirms the thermostat is sending a fan signal. If blower doesn't run, the next logical check is whether the relay or board sends power to the blower. Per NEC Article 430 in standard schematic logic, power path and control path must be traced in order, and B relate to outdoor operation. D affects compressor, not blower. Question 6. Throughout the course of residential HVAC servicing, technicians frequently diagnose heat pumps in defrost mode. Technician Jamie notes that during heating, the outdoor core begins frosting and the system enters defrost mode frequently, even when ambient temperatures are mild above 45 degrees. Which of the following is the most probable cause of excessive defrost cycling in this situation? A. Indoor EXP stuck open causing soup heat. B. Reversing valve solenoid failure. C. Defrost sensor incorrectly sensing temperature. D. Compressor winding failure. Answer. Correct answer. C. Defrost sensor incorrectly sensing temperature. Explanation. Frequent defrost in mild weather is often due to a faulty defrost sensor or thermostat reading incorrect coil temperatures. According to manufacturer service bulletins and RE performance guides, defrost cycles are triggered by sensor inputs, and D don't affect defrost logic, and B would likely cause no defrost at all. Question 7. From a practical standpoint, what is the consequence of oversizing a residential HVAC system, particularly in humid climates such as the southeastern US, when proper manual J-load calculations are not performed? A. The system will cycle longer, improving dehumidification. B. Electrical consumption will drop due to faster cycles. C. The equipment will short cycle and provide poor humidity control. D. Oversizing compensates for heat gain during peak hours. Answer. Correct answer. C. The equipment will short cycle and provide poor humidity control. Explanation. Oversized systems cool the space too quickly to remove adequate moisture, leading to high indoor humidity. Short cycling increases wear and decreases CO efficiency, contrary to CAM manual J and S standards. Proper sizing ensures latent and sensible loads are matched. Option D is a misconception that leads to poor design outcomes. Question 8. In light of recent developments in refrigerant regulations, technician Anna is performing system evacuation before charging a new R400 Tina residential split system. She pulls a vacuum to 500 microns and holds it for 15 minutes, then observes a rise to 1500 microns. What is the most accurate interpretation of this result? A. Moisture is evaporating off the internal surfaces. B. The system is ready to be charged. C. There is a leak or moisture still present in the system. D. The vacuum pump is not adequately sized. Answer. Correct answer. C. There is a leak or moisture still present in the system. Explanation. A rise above 1000 microns indicates potential leaks or retained moisture per HEPA Section 608 and Industry Vacuum Guidelines. A rise to 1500 suggests the system is not sealed or dehydrated. Only when vacuum stabilizes below 500 microns for 10 plus minutes is charging acceptable. Moisture evaporating may cause a brief rise, but not to this extent. Question 9. Taking into account standard safety controls in electric furnaces, which component is designed to automatically shut off power to the heat strips if excessive temperatures are detected, preventing a fire hazard? A. Sequencer relay. B. Limit switch or thermal cutoff. C. Transformer. D. Thermostat. Answer. Correct answer. B. Limit switch or thermal cutoff. Explanation. Limit switches monitor temperature and open the circuit if it exceeds safe thresholds per NEC 424 and all standards. These are critical for preventing overheating in electric resistance heat. Sequencers control staging but not safety shutdown. Transformers convert voltage and thermostat signal demand, not safety cutoff. Question 10. While examining a residential service call history, technician Brian reviews work orders that lack detailed notes about previous system pressures, refrigerant type, and repairs performed. He is unable to determine prior service steps and refrigerant type used. What is the most significant risk of this documentation failure? A. Inability to schedule future appointments accurately. B. Miscommunication with dispatch about tools required. C. Violating EPA refrigerant tracking requirements and risking cross-contamination. D. Increased time spent explaining work to the homeowner. Answer. Correct answer. C. Violating EPA refrigerant tracking requirements and risking cross-contamination. Explanation. Incomplete documentation can result in EPA Section 608 violations if refrigerant usage isn't logged or incompatible refrigerants are mixed. Accurate records also support warranty and system diagnostics. And B are operational concerns, not legal or technical. D may happen, but it's not the critical compliance issue. Question 11. Through careful analysis of system design, technician Darren evaluates a residential air conditioner where the high side pressure is unusually high, the condenser fan is operating normally, and ambient temperature is within range. He also notes a hissing sound near the condenser coil. What is the most likely explanation for these symptoms? A. TSV bulb secured to the suction line. B. Dirty evaporator coil reducing airflow. C. Non-condensable gases trapped in the condenser coil. D. Indoor blower capacitor failure. Answer. Correct answer. C. Non-condensable gases trapped in the condenser coil. Explanation. Trapped non-condensables like air or nitrogen cause high head pressure and inefficiency. This may result from improper evacuation, violating EPA Section 608 and manufacturer evacuation protocols. The hissing may indicate pressure fluctuation. TXV or evaporator issues would affect the low side. A failed blower capacitor affects indoor airflow, and not condenser pressure directly. Question 12. Among the various thermodynamic principles affecting residential systems, which concept explains why increasing the evaporator coil surface area improves heat absorption efficiency, assuming airflow and refrigerant mass flow remain constant? A. Sensible heat ratio increases due to coil volume. B. Enthalpy change decreases and pressure increases. C. Heat transfer increases due to extended contact time. D. Latent heat becomes more dominant with larger coils. Answer. Correct answer. C. Heat transfer increases due to extended contact time. Explanation. According to ASHRAE fundamentals, increasing coil surface allows more contact between warm air and cold surfaces, maximizing heat absorption. This enhances overall efficiency without changing refrigerant mass flow. And D. Misunderstand thermodynamic ratios. B is incorrect. Enthalpy difference drives heat exchange, and increasing area does not increase pressure. Question 13. In what ways can improper brazing during refrigerant line installation lead to long-term system inefficiency or failure in residential HVAC applications? A. It reduces indoor coil thermal conductivity. B. It causes high refrigerant velocity through capillary tubes. C. It leads to scale formation or internal restrictions. D. It breaks compressor windings from heat exposure. Answer. Correct answer. C. It leads to scale formation or internal restrictions. Explanation. Improper brazing can cause oxide flakes or slag to form inside the tubing, eventually leading to restrictions, especially at ESVS or capillary tubes. This violates best practices outlined in USER's and NATE guidelines. Is unrelated. If conductivity is unaffected. B is refrigerant flow design issue. D is rare and more related to electrical fault, not brazing. Question 14. Considering the evidence from recent airflow testing, technician Mikkel investigates customer complaints of uneven temperatures throughout a two-story home. Airflow at distant registers is weak despite a properly sized blow motor and clean filters. Which of the following is the most likely issue causing this imbalance? A. Incorrect refrigerant metering device selection. B. Undersized or poorly designed branch ducts. C. Oversized condenser coil increasing static pressure. D. Compressor short cycling due to low suction pressure. Answer. Correct answer. B. Undersized or poorly designed branch ducts. Explanation: improper duct sizing, layout, or balancing is a major cause of uneven airflow in residential systems. According to CAM Manual D, airflow distribution relies on correct duct size, layout, and total equivalent length. The blower can't overcome excessive friction loss in restrictive ducts. Other answers relate to refrigerant flow or cycling, not airflow. Question 15. From a historical standpoint, why is Ohm's law foundational to diagnosing residential HVAC electrical problems, particularly when testing motor windings and circuit continuity? A. It helps determine refrigerant saturation temperature from pressure. B. It allows voltage drop to be calculated when resistance is unknown. C. It predicts load imbalance in capacitor. D. It relates voltage, current, and resistance to identify open or short circuits. Answer. Correct answer. D. It relates voltage, current, and resistance to identify open or short circuits. Explanation: Ohm's law, V equals R, is fundamental for diagnosing circuits. Measuring continuity or checking motor windings involves identifying opens or shorts using resistance and voltage. This is crucial per NEC Article 430 and NFPA 7 tie for motor and branch circuit protection. Relates to refrigeration, is incorrect without resistance, and C is capacitor specific. Question 16. To illustrate this point, technician alert is called to investigate a residential unit that runs but provides no cooling. She measures normal static pressure, finds no frost on the evaporator coil, and notes a low amp draw on the compressor. The system is properly charged and airflow is sufficient. Which of the following is most likely the root cause? A. Compressor internal valves are damaged. B. Condenser coil is oversized. C. Suction line is not insulated. D. Blower motor is oversized. Answer. Correct answer A. Compressor internal valves are damaged. Explanation: internal valve failure leads to reduced compression ratio, resulting in a running but ineffective compressor. Amp draw drops due to lack of resistance. This condition is difficult to detect without understanding compressor internals and aligns with RA manufacturer diagnostics. Other options don't account for zero cooling with normal charge and airflow. Question 17. The effectiveness of a residential HVAC technician often depends on their communication with homeowners. Technician Robert is called back to a home for the third time in 2 weeks regarding inconsistent cooling. Previous visits involved filter changes and refrigerant adjustments. The homeowner expresses frustration. What should Robert prioritize in this situation? A. Blame external factors like extreme weather patterns. B. Recommend immediate system replacement. C. Carefully explain his diagnostics and involve the customer in the inspection. D. Avoid technical discussion and focus on calming the client. Answer. Correct answer. C. Carefully explain his diagnostics and involve the customer in the inspection. Explanation: transparency and education build trust and reduce callbacks. According to HVAC Excellence and NATE Soft Skills modules, technicians should explain their methods, show visual proof like coil conditions or airflow readings, and empower the homeowner with understanding. D may seem helpful but lacks transparency, and B, deflect responsibility. Question 18. The foundation of electrical protection in HVAC systems includes fuses and circuit breakers. In a residential air handler, what is the purpose of using a dual element time delay fuse instead of a standard fuse? A. It trips instantly during low voltage faults. B. It ignores short circuits to allow startup. C. It withstands inrush current during motor startup. D. It isolates the equipment ground from the neutral wire. Answer. Correct answer. C. It withstands inrush current during motor startup. Explanation: dual element time delay fuses delay tripping under short bursts of high current. B. G. Motor starting per NEC 240.6 dB. This avoids nuisance tripping while still protecting against sustained overloads. And B are incorrect descriptions, and D is unrelated to fuse function and pertains to grounding per NEC Article 250. Question 19. In the absence of proper refrigerant recovery practices, what are the legal and environmental consequences a technician could face if venting refrigerant during a residential system repair? A. It reduces system efficiency but is not illegal. B. It increases compressor wear but is a customer issue. C. It violates EPA Section 608 and can result in heavy fines. D. It is allowed if system charge is under £5. Answer. Correct answer. C. It violates EPA Section 608 and can result in heavy fines. Explanation. Deliberately venting refrigerants like R400 TINA violates EPA Section 608 Clean Air Act, carrying fines over $44,000 per incident. Recovery machines and proper storage are mandatory. Option D is false. There are no exemptions by weight. Option and B ignore the legal consequences and incorrectly shift responsibility. Question 20. The growing trend in smart maintenance includes scheduling residential system checkups before seasonal demand peaks. Technician Zara performs a spring PM and finds a slight vibration in the outdoor condenser fan, minimal debris inside, and a dual-run capacitor measuring 4.1 off on the fan side when it's rated for 5.0 off. What is the appropriate next step? A. Leave the capacitor since it is close to rating. B. Clean the debris and lubricate the motor bearings only. C. Recommend replacing the capacitor before failure. D. Add hard start kit to assist the fan. Answer. Correct answer. C. Recommend replacing the capacitor before failure. Explanation. Capacitors below plus 6% of rating are considered weak. 5.0 off capacitor reading 4.1 off is 18% below nominal, violating manufacturer specs and preventive maintenance best practices. Early replacement prevents costly emergency service. Lubrication and debris removal are good practices but do not address electrical degradation. Question 21. As a result of a service call for a non-operational residential air conditioning system, technician Arjun measures 0 volts at the 24th thermostat terminals despite proper incoming 240 at the contactor line side. The transformer primary side shows correct voltage, but the secondary shows 0. What is the most likely cause of this failure? A. Open circuit on the thermostat wire. B. Defective contactor coil. C. Blown low voltage fuse or open transformer secondary winding. D. Tripped high pressure safety switch. Answer. Correct answer. C. Blown low voltage fuse or open transformer secondary winding. Explanation. If the primary has voltage but the secondary does not, the transformer is either internally open or the fuse on the 24th side is blown. This aligns with NEC Article 725 and control voltage diagnostic logic. An open stat wire A would still allow voltage at the transformer. D would not interrupt the 24th entirely. The contactor coil doesn't affect transformer output. Question 22. Based on the information from a recent winter diagnostic call, technician Rebecca observes that a residential heat pump's outdoor coil is frosting rapidly. The unit enters defrost mode but never fully clears the frost before returning to heat mode. Which issue is most likely responsible for the incomplete defrost cycles? A. Low refrigerant charge preventing full coil heating. B. High indoor humidity increasing coil icing. C. Shorted reversing valve coil. D. Faulty defrost control board or sensor. Answer. Correct answer. D. Faulty defrost control board or sensor. Explanation. Incomplete defrost cycles typically point to a failure in the defrost control board or its sensor, preventing sufficient duration or incorrect termination. OES specifications and RE guidelines require defrost operation to run until frost is fully cleared. Low charge should cause frosting but would affect cooling heating too. Stuck reversing valve would prevent defrost entirely. Question 23. To better understand a system's efficiency, technician Troy measures the following. Subcooling of 5 deg and superheat of 26 deg on fixed orifice residential AC system. Ambient temperature is 85 deg and indoor wet bulb is 64 deg. What does this combination of values most likely indicate? A. Proper charge and airflow. B. Overcharged system with restricted airflow. C. Undercharged system or refrigerant leak. D. Faulty thermostat calling for low cooling. Answer. Correct answer. C. Undercharged system or refrigerant leak. Explanation. High superheat and low subcooling on a fixed orifice system strongly suggest undercharging or a refrigerant leak. The evaporator isn't flooded with refrigerant and insufficient condensation is occurring. Per EPA section 608 in ASHRAE diagnostic charts, this pattern reflects low refrigerant mass flow rate is false because the values are out of spec. Question 24. With respect to standard maintenance procedures, technician Hannah performs a spring inspection on a heat pump and discovers a matted, dirty condenser coil with visible debris accumulation between fins. She notes that pressures are higher than normal and amp draw is elevated. What should Hannah do first? A. Replace the fan capacitor. B. Add refrigerant to reduce head pressure. C. Clean the condenser coil using appropriate methods. D. Reduce the blower motor speed. Answer. Correct answer. C. Clean the condenser coil using appropriate methods. Explanation. A dirty coil prevents effective heat rejection, raising head pressure and current draw. According to manufacturer PM guides and ASHRAE standards, coil cleaning is essential for energy efficiency and compressor protection. Adding refrigerant B would worsen conditions. Fan capacitors or blower settings don't address the root issue here. Question 25. One might argue that choosing alternative refrigerants in residential applications must balance environmental and performance considerations. Which of the following is an accurate statement regarding R400 TINA compared to R22? A. R400 TINA has lower operating pressure and LDW. B. R400 TINA operates at higher pressures and has zero op. C. R400 TINA is compatible with mineral oil-based systems. D. R400 TINA can be topped off without full recovery. Answer. Correct answer B. R400 TINA operates at higher pressures and has zero op. Explanation. R400 TINA operates at 5070% higher pressure than R22 and has zero ozone depletion potential op, which aligns with EPA, SNAP and Montreal Protocol mandates. However, its global warming potential is still significant. It requires PO-oil, not mineral C, and must be recovered before servicing. D. Incorrect. Question 26. The central argument for diagnosing airflow-related complaints begins with understanding how static pressure affects system performance. Technician Marcus records a total external static pressure ESP of 1.15 for a system rated for 0.5 is the most likely consequence of operating under these conditions. A. Compressor overheating due to increased suction pressure. B. Efficient dehumidification due to low airflow. C. Restricted airflow leading to coil freezing and blower failure. D. Increased velocity leading to better duct heat transfer. Answer. Correct answer. C. Restricted airflow leading to coil freezing and blower failure. Explanation. High ESP indicates duct restriction or undersizing. This severely limits airflow, which can drop coil temperatures below freezing, resulting in frost disformation and motor strain. A CAM manual D and airflow diagnostics warn that exceeding rated ESP leads to premature system failure. A is reversed logic. D is a misconception of velocity increases. Overcome friction loss. Question 27. Focusing specifically on installation of new residential systems, technician Naomi observes that the suction line is significantly longer than the manufacturer's maximum recommended length. She also notes multiple 9-tided bends in the line set. What adjustments should she consider to ensure proper compressor oil return and efficiency? A. Increase suction line diameter and add oil traps. B. Decrease condenser fan speed. C. Increase subcooling via refrigerant overcharge. D. Add filter dryer at the evaporator outlet. Answer. Correct answer A. Increase suction line diameter and add oil traps. Explanation. Long suction lines and excessive bends reduce oil return and refrigerant velocity. Manufacturer guidelines and ASHRAE 15 recommend upsizing suction lines and adding oil traps at elevation changes to prevent oil pooling. Subcooling or fan speed do not affect oil return. Filter dryers are useful but not corrective for this issue. Question 20. The most significant aspect of motor control in residential blower assemblers involves understanding ECM technology. Technician Illy replaces a failed PSC blower motor with a standard ECM without reprogramming the controller. The blower does not start and no fault code is shown. What is the likely reason for this? A. The ECM requires a capacitor that wasn't installed. B. The wiring harness is reversed. C. The ECM must be programmed to match system profile. D. The transformer output is too low. Correct answer. C. The ECM must be programmed to match system profile. Explanation. Most ECMs, especially constant airflow models, require factory-specific programming for airflow, static pressure response, and operation logic. Plug-and-play substitution is not viable. PCSES use capacitors, but ECMs don't. A. Wiring reversals may cause errors, but not silent failure. Load 24 would produce additional faults or behavior anomalies. Question 29. The correlation between combustion analysis and code detection in residential gas furnaces cannot be overstated. Technician Jasmine performs a combustion analysis and records CO levels of 150 ppm in the flue gas. No CO is detected in the living space and the homeowner has no complaints. What is the correct action Jasmine should take? A. Leave the system running as there is no indoor CO detected. B. Inform the homeowner but notice within normal limits. C. Red tag the unit and shut it down for safety. D. Increase return airflow to dilute the mixture. Correct answer. C. Red tag the unit and shut it down for safety. Explanation. CO levels above 100 ppm in flue gas indicate combustion issues. According to NFPA 54, ASHRAE 103 and ANSYS 0.47, the system must be shut down and serviced to prevent unsafe operating conditions, even if indoor CO is undetectable. Vent failure or future cracks could lead to co-infiltration. Dilution, D, is not fixed. Question 30. While it is true that service documentation helps track system history, what is the primary technical benefit of logging temperature, pressure, and electrical readings during every residential service visit? A. It helps the dispatcher determine work order priority. B. It satisfies legal protection against lawsuits. C. It provides a performance baseline for future diagnostics. D. It guarantees customer satisfaction scores improve. Correct answer. C. It provides a performance baseline for future diagnostics. Explanation. Documenting readings allows technicians to compare against past values during future service, enabling faster, more accurate troubleshooting. This is part of best practices outlined by Nate and the Cat. Legal or customer satisfaction, B and D, may benefit indirectly, but technical diagnostics and trend analysis are the main purposes.